how it goes. All right, so in the first study guide, 3.1, overview of the lymphatic and nonspecific innate response of the immune system. The immune system as a system is very different from the rest of the organ systems that we have in the body. All the other systems in our body do, in fact, have organs, multiple tissues working together to provide a function, like the heart and the cardiovascular system and the blood vessels there, and lungs in the respiratory system, and the alimentary canal in the digestive system. But the immune system is made of only cells. There are no organs of the immune system, and they're just the 5 different types of white blood cells. And so therefore, since there are no organs, the immune system piggybacks off of the lymphatic system in order to utilize the organs present there, like the lymph nodes, the spleen, thymus, bone marrow, and so they work very closely together in providing an ability of your body to defend itself against invasion. But the lymphatic system has much greater function than just being the scaffolding for the immune system, and so that's that very first question explained the first 3 functions of your lymphatic system. Is kind of like the objectives that I have here. What are the important functions of lymphatic vessels? Where does lymph come from? What's the composition of the tissue and what they do? So so we'll hit all 3 of those things as we go down through my information that I have on the lymphatic system, and then we'll go to the table that you had to fill out. So when, if you remember back with the cardiovascular system, when we were looking at capillary exchange, at the arterial end of a capillary bed, we have hydrostatic pressure is the dominant force there, causing fluid to be extruded from the capillaries. So leaves the capillaries, goes into interstitial fluid. And then on the venular end of the capillary bed, we have osmotic pressure, which draws the fluid back into circulation so that the blood doesn't become viscous, so that we don't have edema, so that all our fluid doesn't drain out into our tissues at the capillary level. However, the hydrostatic pressure at the arterial end is greater than the osmotic pressure at the venular end, and therefore not all of the fluid that comes out on the arterial end is returned at the venular end. So every day, 3 liters of fluid will remain in our interstitial spaces. So out there within the tissues, with the capillary beds running through them, is in a day 3 liters of fluid. But remember, we only have 5.25 liters of blood in us at any one time. And so if we let that material stay out in our tissues, our blood would become so viscous within a day that it wouldn't flow anymore. So what we have, in addition to the blood capillaries, we have lymphatic capillaries, or lymph capillaries. They'll be found in the lymph connective tissue, the loose connective tissue that is surrounding the capillaries within the tissue beds. And so they will return this interstitial fluid back to circulation. Notice there are no lymphatics present in bone marrow or the central nervous system, and I'll go ahead and address that right now. I'm just going to maybe not address that, but I might as well. So bone marrow, we don't need lymphatics in our bone marrow because we don't need to be taking diseases to our bone marrow. The lymphatic capillaries are very permeable, and we do not want any transported material to there, nor do we need any material that's in bone marrow, namely the cells, leaving the bone marrow and entering the lymphatic system and having blood cells present there. So in the bone marrow, we just have the sinusoid capillaries, which are very permeable, that allow the blood cells that are created in bone marrow to only get into capillary beds. Central nervous system, remember we have continuous capillaries in the central nervous system and a blood-brain barrier. So things are very tightly regulated within the CNS, and even the cerebrospinal fluid that's created will go back into sinuses that we have in the cranium, so that there is no need for lymph capillaries to be present in the CNS either. We want to just really keep a tight hold on that exchange process that's happening in the central nervous system. So these vessels are a one-way transport system. They will start in the tissues and they will return back to circulation. They'll return back to the subclavian veins, which I'll show you in just a little bit. And because they are super permeable, anything that's in their interstitial fluid will have the ability to get into lymph circulation. So proteins, any plasma proteins, any clotting proteins, any other proteins that might have leaked through the capillaries during inflammation, for example, need to be removed from the interstitial fluid because we don't want to throw off that colloid osmotic pressure that's present within the capillaries due to the presence of albumin. We don't want tissue, or we don't want fluid staying in the tissues, and if there's protein in the tissues, then it will have the ability to draw fluid toward itself. So all the proteins that leak out have to be removed. Any cellular debris has to be gotten rid of, pathogens, and unfortunately cancer cells. Not necessarily unfortunately, because the cancer cells would be presented then to the immune cells so that they can be destroyed. But you've probably heard about if you're doing a breast cancer exam, self-exam, or testicular cancer self-exam, and you're checking for the testes, you're checking for the breast to see if there's any abnormalities, any lumps or anything in there. But that's not the only place you check. You also, with the breast, go and check the axillary lymph nodes, and in the with testicular cancer, then you check the inguinal lymph nodes to make sure that there is no inflammation in those lymph nodes, indicative of the presence of cancer and your immune system trying to fight that off. So, so all of that can enter the lymph capillaries and then has to be carried back to circulation. Now, you do not want to carry all of that material back into the bloodstream, because remember, our bloodstreams are aseptic. There should never be any germs present in our blood at all, and so we have to clean that along the way. And so as the lymph capillaries are coming back together and forming lymph vessels and returning back to the subclavian veins, then the lymph nodes will be cleaning stations that they will encounter along the way. So that's the first function of your lymphatic system, is to collect this fluid and return it back to circulation. The second function of the of the lymphatic system, is to absorb dietary fats from, well, absorb's the wrong word, to collect the absorbed dietary fats from the small intestine and then return that back to circulation. So in the middle of the peg-like extensions from the mucosa within the small intestine, whether you're talking about the jejunum or the ileum, well, duodenum too, all three sections of the small intestine, there will be folds within the mucosa called plicae circularis, and coming off of the plicae will be these little finger-like things called villi. And in the center of a villus, there will be a blood capillary bed, and there will be a lacteal. And the lacteal will be a single lymph capillary, and it will absorb the digestive fats. Okay, so whether it's coming from the small intestine or it's coming from everywhere else in your body, the interstitial fluid that passes into the lymph vessels will then be called lymph, and then the lymph, and I'll show you a picture in just a second how the lymph capillaries come together to form lymph collecting vessels that are going to come together to collect larger lymph vessels, and then finally there are two ducts that return the lymph back to circulation. So the vessels are very much like veins, but they're thinner walled than veins are. In fact, they are very, very innocuous. You can't really notice them when you're looking at a cadaver. In fact, if I haven't been pointed out a lymph vessel, I probably wouldn't notice it. I would probably just assume it's part of the connective tissue. And I've dissected a lot of cadavers in my day, but I've seen lymph nodes here and there, but haven't tried to follow those lymph vessels and find out where they are. They do have more valves because there's so much less pressure in the vessels that they can easily flow backwards, and we don't want that to happen. So lots of valves, and they anastomize more than veins do, which means interconnect with one another. Typically they're found with the superficial veins, but the deep lymphatic vessels are found with the deep arteries. And then I'm not going to go into the red line thing. That's for something else. Okay, so that's the second function, and then the third function, of course, is going to be tied with the immune system. So here is a diagram showing the origin of the lymphatic vessels right here within a capillary bed, for example. And then you notice that they're going to connect more. They're going to come together and join and form these lymph vessels. You can see all these little pea-looking things in here are actually valves that we find within the lymph capillaries, the lymph veins, lymph vessels, sorry. And then you'll notice that the lymph vessels will converge onto a lymph node, and that's what these little lima bean looking things are. And then you'll notice that there's several afferent vessels that come into the lymph node and very few efferent vessels that take the lymph away. And what that does is slow down the movement of the lymph within the lymph vessel, the lymph node, so that it can be processed by the lymphocytes that will be hanging out in there and be presented by the macrophages that will be coming to the lymph nodes as well. So then the material will be checked probably several times on its way back into circulation, and then finally will enter back here into the venous system. And so it'll enter at the junction of the internal jugular vein and the subclavian vein on both the left and right side of the body. If we look at this picture over here on the right, you can see how the lymph capillaries just kind of weave their way through the capillary beds, and then you can see the tissue cells that are all surrounding there, and then this arrow indicating where the tissue fluid is going to enter at the very end of the lymph capillaries. This picture shows what a lymph capillary really looks like. You can see that the endothelium overlaps itself, producing these little mini valves, and then we have these little filaments that hold it in place. But what happens is that the fluid is going to push on the cell right here, and fluid will come in, but then as soon as the fluid comes in, then as the fluid falls backwards, it shuts the valve so that there isn't any backflow of lymph out of the end of the capillary. Okay, so that makes them very, very permeable. It's just going to be the pressure of the interstitial fluid in here pushing on the flaps that will allow the fluid to enter into the capillary. So anything that's in the fluid, like we said, cellular debris, proteins, pathogens, macrophages, whatever might happen to be out there, will very easily enter the lymphatics. This picture shows what a villus looks like. So here is the mucosa of the small intestine, and these are the little peg-like extensions that go in there to increase surface area for absorption. This is all simple columnar epithelial tissue with goblet cells all around here. And so as the digested fats that are out here in the lumen pass through in a fairly complicated process, a lot more difficultly, is that even a word? It's a lot more difficult for the fats to pass in here. You would think, because they're lipids in the membrane, they do, but while they're out here in the lumen, then we'll talk about that with digestion. Then they pass through the cell, and then they have to pass out of the cell and then back into the lacteal. And so there's also a little more complicated process instead of just strict diffusion going on. So here's the lacteal, and so then the lacteal will then carry back to lymphatic vessel and then go and enter into circulation. All right, so this picture here shows how lymph vessels return back to circulation. So we'll notice that the right and left sides of the body are not evenly divided as to lymph return. The upper right side of the body, so this thoracic region and then the head region and the arm region on the right side, will all drain into a vessel called the right lymphatic duct. And then over here on the left, all of this, the right or left side of the head, left arm, left thoracic, and the whole lower half of the body will all come up to here and then start in an enlarged area, kind of like a catchment basin called the sternochyli, and then go up into the thoracic duct and then into the left subclavian vein. Okay, so here is that information, and there's the thoracic duct. All right, so let's just go ahead and talk about this. I'm going to come back to the chart, but it says, where does your lymph fluid drain back into the blood system? So we covered that. How do lymph vessels propel fluid back to the heart? That's this right here. So lymph transport is going to be almost exactly like venous return. So it's going to have to rely on skeletal muscle contraction and the valves, respiratory pump, all of that, same as venous return, to get the lymph back to circulation. Also, the pulsation of the pulsatile nature of arteries and the smooth muscle in the lymphatic trunks will also help milk the lymph back towards the circulation. If you have a swollen area, what do we always say? Elevate it, and that will help drain the fluid back. But if you have an infected body part, then we want to keep that lower than the level of the heart so that the infected material will stay down at the site of infection so that your immune system can handle that without having that infectious material work its way back into circulation. So that's that third bullet. Immobilizing a badly infected body part will hinder the flow of inflammatory material, and it works so well that 3 liters of fluid will return back in 24 hours. Okay, so I'm going to go back to the chart and go through just a few of the first columns, and then we'll get to the spleen and the thymus in a minute. So as far as lymphatic vessels, main role, we got to return the lymph nodes back to circulation. Locations everywhere in the body we saw interspersed within the capillary beds. Special characteristic of the tissue. I'm not sure what they're after in that particular instance. I know why they did that for the rest of them, but I would just say it's very similar to what veins are like. And then white blood cells found there. Macrophages will be found there. Macrophages. We will have some circulating lymphocytes for immune surveillance. You probably could find all of them there. Eosinophils and basophils, but definitely neutrophils and monocytes or macrophages will be found within the lymphatic vessels. Okay, lymph nodes, their main role is to clean out the lymph. And I'm going to put the nodules, I'm just going to do the lymph nodes. So their main role is to just process that lymph. Oh, let's take a look at, here's what a lymph node looks like. So the locations, there are 3 main places that we have aggregations of lymph nodes. We have cervical, axillary, and inguinal. We also have Peyer's patches associated with the small intestine. The appendix is kind of like a lymph node as well. It's kind of more like a tonsil, really. But special characteristic of the tissue, it's got a capsule on the outside, and it's got 2 different layers. We have an outer portion. We have an outer portion called the cortex and an inner portion called the medulla. And I don't know that we need to get into the specifics. No. Oh, well, there's a question. It says, when your body is fighting an infection, why do your lymph nodes or lymph nodules become tender and swollen? All right, so here's the deal. Lymph fluid is going to come in through these more numerous afferent vessels, And then you're going to have both B cells and T cells within the cortex and the medulla. B cells out here in the cortex and T cells more in the medulla. And what's going to happen is that this is where antigen challenge is going to be encountered. So when an antigen is being brought to the lymph node by a macrophage or some other antigen presenting cell, or it floats in on its own, then the T cells and B cells, if they are there, that have the B cell or T cell receptor for that particular antigen, are then going to be selected. We call it clonal selection. I'll get more into that, I'm sure, in another study guide. And then they go through clonal expansion. And so we're going to increase the number of either the T cell or B cell or both that have the receptors for that particular antigen. So essentially you produce an army really quickly in that lymph node, and then you go to war against the antigen. And so they swell, they become tender because they are chock full of those T and B cells or lymphocytes that are designed to fight that particular antigen that was brought to the lymph node. Okay, so special characters, well, we went through that, white blood cells. So hanging out in the lymph nodes will be the T and B lymphocytes. They don't stay there forever. They migrate through them. They will constantly be circulating through the lymphatics and through the bloodstream, but they're going to hang out there for a while and wait for the antigenic challenge. And so those are going to be, so macrophages and lymphocytes will be the white blood cells that we find within the lymph nodes. All right, I'm going to have to leave it there, and got to go pick up my daughter from school. So I will come back to this in a minute.